Hi guys, welcome to the tutorial for designing the handle component of the speculum. So the handle is the most significant component of the speculum. It is essential for the button locking mechanism for the bottom bill, and most importantly for the zip tie locking mechanism that opens and closes the two bills and adjusts and holds it in one place, as well as adjusts it for size. So here is how the finished part will look like. But now I will walk you through all the steps that gets us to this final design. So first, we need to start on the front plane and create the base of the handle. So this gives us the basic shape of the handle. So there is a top arc with a radius of 0.63 inches that forms the base for the chamber that will hold the bottom button and the bill. It is 1.5 inches wide and 1.4 inches high. However, on either side of the arc, we have two higher tips that are each 0.15 inches and wide and 1.62 inches high. These two tips are a part of the fork that will later connect to the lever and hold the zip tie. I will explain the purpose of these features later in the video. The total height of the handle is 4.1 inches, where the lower 2.5 inches is 0.5 wider than the top to better ergonomically fit in the physician's hand. The narrower part will hold a zip tie, which I will describe later as well. The entire handle is extruded out a blindly 0.25 inches. But in order to make the handle better fitting in the user's hand, we have extruded the bottom handle portion for an extra 0.275 inches. We have then filleted the edges, I'll show you here, of these edges as well as these edges that are combining both the narrow and wider parts of the handle with a radius of 1 inches. We then need to fillet the extra edges of the side, all edges of the side of the handle with a radius of 0.275 inches, making the surface as round and smooth as possible and thus easier to hold. We also need to fillet the edges of this chamber with a radius of 0.4 inches to make the chamber also more rounded and smooth. So next we have to go and create the chamber to hold the button lock, spring, and casing. The chamber is going to be 0.6 inches deep and consists of an arc of 0.75 inches radius, and its tip is also 0.75 inches deep into the surface. It is then extruded 1.3 inches out front from the base of the chamber that was made in the first part. So it's extruded out this way from this base. Next, the bottom edge of the chamber is also filleted with a radius of 0.35 inches to make the chambers all smooth and rounded. However, in order to separate the chamber from the fork, we have made an extra cut in the back let me show you here. That has a radius of 0.56 inches and it's 0.15 inches up from the surface, and it is 0.1375 inches deep. Because this fork will hold the zip tie while this chamber will hold the button locking mechanism. So in order to separate the two, we have included this cut. We then fillet all edges around the chamber with the radius of 0.25 inches, as you can see here. All these edges are then filleted, smoothing the surface of the chamber. The sides of the chamber, of the handle chamber, need to have screw holes in order to incorporate the entire bottom locking mechanism and screw all the components together. Our design employs the use of a binding head screw size 1 with a loose fit. So we used hole wizard to bore 2.38 inches holes on this right side of this chamber. Now we will focus on this fork. So on the back of the handle. So the fork will hold the zip tie as well as connect the lever in order to create the zip tie locking mechanism that will open and close the speculum as well as adjust it to different sizes of openings. So this is done by first creating a hole of diameter 0.15 inches on the right face of the fork. And this hole will be used to connect it with the lever. And since the lever has a cylindrical extrusion, that cylinder will go through this hole and connect it with the handle. So, but in order to secure this hole and avoid it from breaking off the edge of the fork, we need to create an arc of 0.2 inches from the top of the fork and surround the hole and extrude it back 0.15 inches. This hole, along with these two screw holes, are then mirrored onto the left with respect to the right plane. As you can see here, it was mirrored with the right plane. So now back to the, sorry. So yeah, so back to this handle. So since we were keeping the focus on comfort and stability, so when the patient's using the speculum, we have incorporated these 3 ridges on the front and back faces of the handle. These ridges help create friction and with the user's hand, preventing the speculum from slipping from the physician's hand and thus enhancing stability. The 3 ridges in the front are actually different from these 3 ridges in the back. And I will explain to you why. So the 3 ridges in the front are each 0.13 inches wide with 0.15 inches in between each of them, and then the 2 ridges on the side are 0.75 inches from the top, while the middle tall one is 0.25 inches from the top, and they are all 0.25 inches from the bottom as well. However, on the back, it is a little different in that all the other dimensions are the same, but the tall ridge is actually 0.25 inches shorter, and this is because it needs to make way for this slot for the zip tie. So and they are all extruded 0.15 inches. Let me show you. They are all extruded 125 inches out. So the zip tie lock slot that I mentioned earlier is actually created here. So this feature is needed to help, it's designed to fit our zip tie inside the handle and create the zip tie locking mechanism that will open and close the speculum when in contact with the lever. It is 0.4 inches wide and 0.5 inches high, and it is 0.4 inches from the top surface. And it's cut into the handle with a depth of 0.45 inches. And we can then insert our zip tie into here and connect the lever here, and the lever will then be able to use the zip tie and create a working locking mechanism. Yes. So now we have to then fillet the edges surrounding the fork with a radius of 0.25 inches. And then using the same radius, we fillet the edges of the ridges as well with the same radius of 0.25 inches. So now we have to make a hole for the button to fit inside this chamber. So, but first we need to make a reference plane. So this reference plane is actually 0.55 inches from this front face of the chamber. And using this plane, we can then cut a square shaped hole that is 0.75 inches wide and 0.5 inches high. Let me show you a better view. 0.75 inches wide and 0.55 inches high, with a top arc of 0.63 inches and a bottom arc of 0.77 inches. So it is a radius. Since it is square, it is cut 0.75 inches midplane through the reference plane. This chamber also needs to hold a spring inside this hole. And this spring will rest underneath the button inside the chamber. So in order to achieve this, we need to make a circular cut that will fit the spring inside the hole for the button. To do this, we need to make another reference plane. And this reference plane is tangent to the bottom surface of the button hole and parallel to the top plane, as you can see here, of the entire part. From this reference plane, we can then cut out a circle with the diameter of 0.42 inches. And this circle is cut into the bottom with a depth of 0.075 inches, as well as all the way through the top. And we can make a circular indentation to fit the spring in. We can then fillet this edge of this circle with a radius of 0.05 inches to create a nice groove for the spring to sit on. So the spring can rest itself inside this groove. Using convert entities, on this groove, we are able to extrude it 0.225 inches up and create a nice cylinder that can hold the spring in place. And then the face of this cylinder is then filleted with a radius of 0.05 inches. And this entire cylinder with the grooves helps secure the spring in place and not move all around the case. So now we have finished designing the handle and made sure that it has all the functional capabilities we hoped for it to have for our speculum. It acts as the central component for the zip tie locking mechanism by opening and closing the speculum bills by connecting with both the lever and the zip tie. And it also functions for holding the bottom bill and its button locking mechanism with its bottom chamber over here. That houses the button, spring, and the button casing. So this is the final design for our speculum handle. I hope you enjoyed the video and thank you for watching.